Okay, in this video I'm going to do some example problems of sketching various waveforms given a bit sequence. So here I have some little pieces of graph paper, and I've given a sequence of bits, zeros and ones, and it asks you to graph the waveform for NRZ, NRZL, NRZI, and then at the bottom polar RZ or just RZ. And so here, let me follow this along. Each one of these is simply a matter of following the rules. And in NRZ, we have a 0 voltage for a 0 and a positive V for a 1. So it goes something like this. Goes up for a 1, stays at 0 for a 0. If I can do it properly. Okay. And that's what it looks like. And so that's part A. For the NRZL, the rule is that for a 0, we have a positive V, and for a 1, we have a negative V. And so it's sort of upside down from the NRZ, but it also goes both positive and negative. Okay, so in this one, zeros give a positive V. One way to do this is to just fill in all the zeros at the positive voltage. And this is sometimes a better way than just going bit by bit. Here's all the zeros get a positive voltage, the ones are at a negative voltage, and then you fill in these infinitely fast transitions, which would require an infinite bandwidth, as we know. Okay, so there's how you can fill in this one, NRZL. Okay. NRZI is the trickiest of them all. A 0 gives no transition at the start of the bit period, and a 1 gives a transition at the start of the bit period. And because the zeros and ones only determine the transition, we need to be given the previous voltage level. And so the previous voltage level was somehow positive, and so a 0 is the first bit, means no transition at the start of the bit period, and the pattern is voltages plus or minus V naught, and so V naught is V with a subscript 0, and so a 0 means no transition, and if it was positive, it stays positive. And so we're going to have a transition at the start of the bit period every time we have a 1. So here we have a 1 in this bit period, so we're going to have a transition. This one's going to cause a transition here. This one's going to cause a transition here. And so let me fill in the transitions first. Every time there's a 1, there's a transition at the start of the bit period. And I filled those in, and now it's a matter of simply saying, okay, the voltage continues on. So it is at the start of the bit period. When we have a 0, we have no transition, okay? And let's see, at the start of this bit period, none, and then I can just fill this in like so. And so we can double check. Let's see here. Okay, let me make these guys stick to the paper using my, there we go. Okay, so now we can see that we have 3 ones in a row, we have a single one, a single one, a single one, and then 2 ones in a row. So 3 ones in a row make a sort of a squiggle, and 2 ones in a row make a single blip like that. Okay, so finally, polar RZ. This one probably use a little bit narrower pen on, because this one is an RZ, and RZ means that we're returning to 0 in the middle of the bit period, okay? And this polar RZ has a rule that a 0 transitions from a minus voltage to 0. So a 0 kind of looks like this within a bit period, and a 1 looks just the opposite, like that. And the 0 is at a minus. So here's the 0, both of them return to 0 at the last half of the bit period. So the zeros all look like this. And I'll fill in all the zeros first, and then I'll go in and fill in the rest of the waveform. This is, I think, the easiest way to get these things right. And all the ones look like this. And so we have this complicated looking waveform, but in the end, it's a blip upwards for a 1 and a blip downwards for a 0. And if I fill in all these little verticals here, I can finish up this waveform. Okay, so this hopefully is reasonably straightforward, and you can look at these waveforms and grade your homework by looking at this. Okay, I will stop here on this video. I hope this helps.